Hello, welcome back to Python 5. In part 1 today I'm going to be covering slicing, and then in part 2 I'm going to be covering arrays and how to access arrays as well. So let's begin and jump into Jupyter Labs. So here we are. We're covering slicing first in part 1, and then arrays and accessing arrays in part 2. Our upcoming goal is to add a line of best fit to our graph that we've been making from the previous two videos. I'll explain how the gradient works, and that will allow us to find the experimental value for gravity. And also I'll explain how you will use the gradient in the future in physics in all of your experimental laboratories and reports. So let's begin with slicing. So what is slicing? Slicing means to take a segment of your data structure, such as a list or an array, and there's syntax to slicing that's very similar to indexing. The principle works in the fact that these data structures are ordered. An ordered data structure means that every entry has a position number and can be indexed according to its numbered position in the structure. We call its numbered position its index. That's what we call it. So we index structures using the index of an entry. We have seen this in lists and tuples before. This is covered in Python 1, one of the first things that we've done. So slicing is just taking a copy of a segment of your data structure. It works similarly to indexing. So let's see the syntax for slicing, an example to visualize the concept as well. So I've got a list L here, it's numbers 1 through 10. And the syntax for slicing and what these different layouts here return is this. We first call the name of the data structure that we want to slice. In this case, it's L. And then in square brackets, we include a start index, and then a colon, and then on the right-hand side of the colon, we have the stop index, and then we close it off with a square bracket. So this first one returns the items start through to stop -1. So item start is whatever index this is here. So if it was index 1, it would begin at 2, and so your copy, your slice, would include 2 up to wherever your stopping index is, and then it would not include the entry of the stop index. So slicing is exclusive of the stop value from the slice copy. So effectively, this returns the items start through to stop -1. So we'll see an example down below after we've covered the rest of these ones here. We can also take from a specific start value, and we can continue all the way through to the end of the array. So to do this, we just simply specify their starting index, and then on the right-hand side of the colon, where we would have the stop value, we just leave that blank. And that means that the default value is just the last entry in the array. So it will just continue all the way through and take you right up to the end. And that'll return a copy of that. So this layout here, this L and then the slicing, this is actually representative of a copy of whatever that is. It's like what we were talking about with data and functions. So this is effectively a built-in Python function. We've got our parameters, start and stop, and we can also include a step as well. A step is what index do you jump up by? So normally the step is 1, but you can jump up by 2, and that means it will jump up by 2 from the start index each time. But we're not going to cover that because you probably won't need to use it. So next up is you can take it from the beginning up to a stop value. Remember that the stop value will not be included, so it's actually up to stop -1. The slice will go up to the value before the stop value that you specify. You can think about it as the stop value is the first entry that you do not want to include. It's the first entry that you don't want to include in your slice. We can also take a full copy as well. So if we don't specify a start value, if we don't specify a stop value, then we just get a full copy. And that's what this one here is. Okay, slicing obviously doesn't use the word start and stop. We use numbers in place of start and stop. The numbers represent the positions of entries that you want to start and stop at to take a slice. So we'll go into a numerical example now. We've got a list here, 1 through 10, and we're calling it L. And I've got a nested list here as well. I've called it LL. I think that's pretty self-explanatory. You can differentiate them pretty easily. The entries of the nested list are 2 lists here. One's numbers 1 through 4, the other's numbers 5 through 8. So there are 2 entries in the top layer here, and then there's 4 entries in each second layer. And we'll see this later on when we're trying to take a slice that just has the numbers 2 and 3 in it. So I can look at just this first list, 1 through 10, and say I want to take the first half of that list. Well, I'm going to use the syntax, I'm not going to specify a start value, and that means it will start at the beginning, and I want to specify the first entry that I don't want to include. So I don't want to include index 5. Now remember that we begin counting at 0, so 0 is down here, and what you might think 5 is entry 5, but that's not. Entry 5 is actually index 4. 6 is index 5, because it goes 0, 1, 2, 3, 4, 5 here on 6. And 6 is obviously in the upper half of 1 through 10. So we don't want to include it in the first half. So index 5 is the first one that we don't want to include. So the slice will return just the first half. And I'll show you, these are all the results all together. So here's the first one here, 1 through 5. It's worked, excellent. On to the next one. We can take the last half. So the start value, everything's normal. Stop value, first index you don't want to include. So in this case, we haven't specified a stop value. It will just go up and continue to the end of our data structure. So this will return the last half from index 5, which we saw was 6. That's going to be 6 up through to 10. If you look down here in the results, sure enough, here it is, 6 through to 10, right here. Next up, we're taking a whole copy. It's just L, and then don't specify start, don't specify stop. The default is to begin at the beginning, and then end at the end. And we get a full copy, 1 through 10, in the middle here. Okay, now I want to take the middle 4 values in the list. So if we look up here, what are the middle 4? They're probably going to be 4, 5, 6, and 7. So what indexes are we dealing with here? Well, 4 is index 3, and I believe 7 is index 6. However, when we enter the stop value, we want to include the first index that we do not want in our slice, and that would be entry 8, which is index 7. So index 7 is the first one that we don't want in our slice because it's not in the middle. So I'm going to enter 7 in the stop value. So there's a wee bit of a comment here that's just saying it's non-inclusive of position 7, and this is entry integer 8. And we look down here, our list that's been returned is 4, 5, 6, 7, and index 7 has not been included. So that's worked as well. And now we get on to accessing the nested list here. So I've got a variable 2, 3, and I want to assign the data structure into 2, 3. Now the data structure is the slice that we're taking. We start with LL. This is our nested list up at the top here. Here it is. First, we're going to access the top layer. 2, 3 lies in the first entry. That is index 0. So we're going to index first, not slice. We're going to index first to access the data structure that we want. So we go LL down here, LL, and then we're indexing position 0. So we're now down from the top layer into the second layer, where we can now perform a slice to take the numbers 2, 3. So this list is 1 through 4. The indexes are 0, 1, 2, 3, and we want to take just 2 and 3. We want to begin at index 1, and we want to stop at index 3 because it's non-inclusive. That means that 4 will be excluded from the slice. So we want to go 1, 3. And when we do that here, and we print it out, we get 2, 3. So it's worked. We've first indexed, and then we've sliced. That's how this would work on nested structures, and it can work all the way down. You can take as many indexes and slices as there are layers. So, quick wee thing I'm going to cover now before we begin part 2 is negative numbers in indexing. So we can use negative numbers to work from the end of a data structure when indexing. I'll use lists to show the positions numbers when negative numbers are used. So in here, I've got my list. It's a list of values 1 through 6. I've got the positive indexes of each position placed just directly below them to show you very easily what they are. So 1 is index 0, 2 is index 1, you'd have 6 as index 5. And below that, again, I've got the negative indexes. So we actually have negative numbers for indexing as well. And we use them when working from the back of a data structure because we assign the last value of the data structure to index -1. Okay, so down here I've printed out the entries and then the negative positions for them as well. So 6 is the last entry in the list, and the index of it is -1. But it's also got the positive positions as well. It's also index 5. So we've actually got these two systems that we can use to index numbers. We've got the negative positions that are very useful for working from the back of a data structure. And we've also got the positive ones, which are more useful for working from the front. But we'll see that you can actually use both negative and positive to refer to the same thing. So in this case, I've got my list. I'm using index 5. And index 5 is entry 6. And I'm also using my list to -1. And as you can see down here with the negative positions, that is also entry number 6. So when I print this out, hopefully we'll see that it gives us the same value. And sure enough, this is what we get. We get 6 for my list index 5, and we get 6 for my list index -1. And then for this one down here, I'm using my list index -6. Now, this is actually the first value. This is the first entry in our list. However, this would be dependent on the length of your list. Okay, the negative index of the first entry is going to be dependent on how many entries you have, because you can imagine this is counting all the way back in negative numbers, all the way down. And the first negative index is actually equal to the negative of the length of the list. So we've got 6 entries in the list, and the first index in the negative numbers is the negative of the length. Does that make sense? Can you see that? Because we don't start at 0. We start at -1. So that's how that works. This is the end of part 1 now. In part 2, I'm going to cover arrays and how to access arrays as well. And we'll cover indexing and slicing on arrays as well. That's going to be very useful for accessing data structures in your labs, for all the data you collect. So I will see you then. Bye.